Okay, all right, class. So today, we can see from the board that we're going to be talking about different forms of energy. And this is something we learned about last year in 4th grade, so this is prior knowledge. We have some prior knowledge about this topic. Now I'm going to call on someone by the raise of hand, and you're going to describe a form of energy for me, okay? India?
Electrical energy is used for electricity.
Okay, perfect. That's a great example. We have another friend that'd like to answer? Alyssa?
Heat energy is used in microwaves to warm up food.
Perfect. So heat energy, or sometimes it's known as thermal energy, is used in a microwave. Alrighty. Now we're going to read our content and our academic language objective. Content objective. Given a short video, students will complete guided notes with 70% accuracy or 7 out of 10 correct. Academic language objective. Given a video, students will fill out the summary portion of the guided notes to show understanding and engagement with 70% accuracy based on a comprehension rubric. So not very different. We're going to be watching a video and then filling out guided notes based on that video and the information it gives us. But before we do that, we're going to be taking notes on the video. So I want you to look at this paper that we have in front of us in our cubbies. Okay, and it says forms of energy. And here we have on the sidebar, light, thermal or heat, sound, mechanical, chemical, and electrical. And these are the different forms of energy that the video is going to be talking about. And in these blank spaces next to those words, we're going to be writing about those individual forms of energy, okay? So now I'm going to show how we should take notes while watching the video, because we don't have enough time to be writing full sentences because they're going to be talking faster than we can write. So here I have some note-taking strategies. We're going to want to write down key facts. Don't overdo it. Don't write down more than one sentence. Don't even write down a full sentence. Shorthand your notes. Maybe just do half the sentence. If it says it's not safe to look directly at the sun, we just write don't look directly at the sun. And then you're going to want to organize your format, which in this case our notes are already organized for us, and the columns next to them is where we're going to write our notes for each form of energy. So first I'm going to show how I would do shorthanded notes for our example over here. Here we have some facts about the sun. It's not safe to look directly at the sun. The sun is the closest star to Earth. The sun is a giant ball of gas. It is approximately 10,000 degrees Fahrenheit on the sun. The sun could hold 1 million Earths, and we need the sun for light, warmth, and energy. So if I was taking notes on this and I only had a limited amount of time to do so, like you will when we're watching the video, I would write down something like, don't look directly at 10,000 degrees. And maybe something like light, warmth, and our topic for today, energy. It's a little crowded, but we understand what I'm trying to get at. So this is an example of notes we're going to be trying to take while watching the video. Okay, so now I'm going to put our marker back. And we're going to continue. And there we go.
Oh, hey there, fellow scientists. I'm so glad you're able to join me at the amusement park today. Being here among all the people, the sounds, the colors, it always makes me feel so energetic. It's the perfect environment to learn all about the forms of energy. I also have to do something to pass the time while I wait in line for my favorite roller coaster.
By the end of today's lesson, you will be able to identify different forms of energy, explain the relationship between kinetic and potential energy, and describe some ways that energy transforms. Let's get into it.
is the ability to do work, and it exists in a ton of different forms, like thermal, light, sound, electrical, chemical, and mechanical energy. And those are just some of the forms energy can take. In our previous lesson, we observed energy in the form of heat from the sun. Heat is what we call thermal energy, and it's caused by the movement of atoms in an object. It's what's warming our day at the park, popping the popcorn in the food hall, and melting everyone's ice cream just a bit too fast. Thermal energy is especially important because every time energy changes forms, some heat is released. For instance, when you experience...
So here we have some good facts about the second one on our forms of energy list, thermal, heat. Be sure you're listening and writing down key facts. So every time energy is transferred, it loses some heat.
The force of friction by rubbing your hands together. The energy you're putting into moving your body is transformed into thermal energy, heat. Another form energy can take is light energy, which is just what it sounds like. It's the form of energy that is visible to the human eye. Sources of light energy include...
So if you didn't catch that, light energy is a form of energy visible to human eye. Give us a few seconds to write that down, and I'll say it one more time. Light energy is a form of energy visible to the human eye. Now keep writing down key facts you hear.
Natural sources like the sun lighting up the park, and artificial sources like the flashing light bulbs along the rides here. Sound energy is the energy of sound waves. Sound travels as vibrations through matter. Sound can range from the most accelerated screams on the loop to...
So sound energy is the energy of sound waves. Make sure we are following along and listening to the key details.
The loop coaster and the liveliest music, all based on how those sound waves are shaped. Electrical energy is the energy caused by the flow of electrically charged particles, such as electrons. This is the type of...
So the last one on our list is electrical energy. This energy is caused by the flow of electricity charged particles such as electrons. Let's go ahead and write down key facts. I'll pause for a minute for us to comprehend. And moving on.
Of energy we harness as electricity, and it's being used to power basically everything in this park.
Electricity.
Chemical energy is the energy stored in the bonds between atoms. When those bonds are broken, the energy is released. Chemical energy is present in food before it's eaten, batteries before their devices are switched on, and fuels like gasoline or coal before they're burned. That's a lot of energy. Can you think of an example of each of those forms? Pause the video here and jot down your thoughts in your guided notes.
We'll just continue.
When you think about energy, you might think of getting up and dancing, of racing your friends, or of riding a bike. All of those are what's called mechanical energy. Mechanical energy is the energy of motion, and it has two parts, kinetic and potential. Kinetic energy is the energy of objects currently in motion. A skateboarder zooming down the street, a bird flying through the air, and a dog running after a ball all have kinetic energy. If it's in motion, it has kinetic energy. Potential energy, on the other hand, is the energy stored inside an object with the potential to move or change. A sled at the top of a hill, books held over your head, and a stretched rubber band all have potential energy. Usually when we're talking about potential energy, we mean the potential energy that an object has due to gravity and its position above the ground. The higher an object is, the more potential energy it has. Think of a glass of water that's sitting uncomfortably close to the edge of a table. It's currently just sitting still, but it still feels sort of dangerous. The reason it feels this way is because you're aware of its potential energy. Because of its height off the ground, the glass has the potential to fall and cause a big mess, or worse, get your socks wet. Ugh.
In the same way, an apple in a tree or Jack and Jill up on a hill have potential energy. Once they begin to fall, that potential energy starts to change to kinetic energy.
So quick pause, we just learned that part of mechanical energy is potential energy, which is energy stored in an object with a potential to move or change. Now we're going to hear about kinetic energy.
We have a perfect example of an object's mechanical energy shifting between potential and kinetic. The roller coaster. As the ride reaches the top of the hill, it has a lot of potential energy. It's sitting at a great height, and the force of gravity is pulling it towards the ground. And since it's not a really boring roller coaster, it will eventually go down the hill. As it starts to fall, its potential energy from being high in the air converts to kinetic energy, motion. As it gets farther down the hill, more and more of its potential energy changes to kinetic energy. Then, when the ride climbs back up the hill, its kinetic energy shifts back to potential energy.
Who knew an amusement park would be such a great place to learn? Take a second to pause the video here and label where the roller coaster has the most potential energy and where it has the most kinetic energy in the diagram in your guided notes. The conversion between potential and kinetic energy isn't the only energy transformation going on with this roller coaster. Throughout the course of the ride, some of the coaster's mechanical energy is lost. Now remember, energy is never destroyed. It's only transferred or transformed. As the roller coaster moves, its wheels rub along the track, causing friction. Just like when you rub your hands together, that friction causes some of the ride's mechanical energy to change into heat and sound. Because of this change in energy, the coaster can't keep rolling forever on its own. To keep it moving, the ride needs to convert electrical energy, electricity, into mechanical energy. So it'll still be running by the time I reach the front of the line.
Speaking of which, I think it's getting really close to my turn to ride, so let's review everything.
Before we go with the review, next to kinetic energy, I would probably write down the key important detail that motion is a big part of that energy.
We've learned today. Energy comes in many different forms, including thermal, light, sound, electrical, chemical, and mechanical. Mechanical energy is the energy of motion, and it has two parts, kinetic and potential. Kinetic energy is the energy of an object in motion, and potential energy is stored in an object based on its position.
To learn more about the different forms of energy, be sure to check out the practice questions and activities that go with this lesson. I made it out of the ride! Now, if you'll excuse me, I'm going to go convert some potential energy into kinetic energy.
Alrighty, and that concludes our video. Alright, so now that we've taken our notes, I would like everyone to get in their groups and discuss the notes we took and share with your partner anything that they didn't have or that you didn't have, and write that down on your paper, okay? So I'll give us a few minutes for that. And then we're gonna move on to our assessment, which is the guided notes that will be talking about each form of energy we just saw in the video. Go ahead.
For light, I have that it's visible to the human eye, so we can see light.
And then for heat and thermal, I put movement of atoms. They're used for melting ice cream and releasing heat every time energy is transferred.
Yeah, I can imagine. You can get heat from your hands too.
Yeah, friction.
Yeah. Sound, energy of sound waves.
And
All right, just a few more seconds more.
oh, and then kinetic and potential energy when the roller coaster is sitting, that's potential, and when it's going, it's kinetic energy.
Yeah.
All right, you can go back to your seats, leave your partners. Thank you for engaging. So just to recap, for light, it's a form of energy visible to human eye. Heat energy, things we see like that pops the popcorn. The microwave, as one of our friends mentioned earlier. Sound energy is the energy of sound waves. Mechanical energy has both kinetic and potential. Potential is stored in an object with the potential to move or change, and kinetic is the motion. All right, chemical is energy stored in bonds between atoms. And electrical is the form of energy that we see almost every single day with these lights on around us, electricity. Now that we've finished watching our video, we're going to be getting this assessment that's in front of you in your table cuppies. So it's going to be forms of energy, and underneath each of these forms of energy is 3 bullets. On 2 of these bullets will be definitions and descriptions of that form of energy, and the 3rd bullet will be a use of that form of energy that we saw in the video. So there was many examples he gave, so I'm hoping you wrote some of them down. And after that, you will fill out the summary portion with a brief sentence about each form of energy, okay? So I'll hand that out for anyone who didn't get it. And now that we've all turned that in, we will move on to our exit tickets. Just to wrap up our lesson today. And our exit ticket should be right in front of you, in our table cubbies right there. And can someone please read to me what it describes to do? Raise your hand. India?
Describe one form of energy and 2 facts about it.
All right, perfect. So that's our exit ticket today. We're going to be working independently. We are going to not be using our notes. And when you're finished with that, you may turn it in and then go to your next class. All right, thank you.